Okay, in this lesson we're going to look at dividing with exponents. We're going to look at the quotient rules of exponents. So if you will please set up your notebook and write down the essential question, and when you are ready, restart the video. Okay, so quotient rules. Quotient rules, remember quotient means division, so we are talking about division. And just like we talked about previously, I want to remind you that the rules apply exponent to exponent. Okay, so if we say to do something like add or subtract or multiply, we're talking one exponent to another. Okay, so the first rule is quotient of powers. Quotient of powers is just like product of powers. All right, I'm going to double check I may have said that name right. Product of powers, yes. See, I get the names mixed up too. So it says to divide powers. So we've got two powers, and they have the same base, so just like product of powers. This time, though, we're going to subtract the exponents. Okay, because we're dividing. Multiplying, we end up adding because our numbers are getting bigger. But dividing, we subtract because we start to eliminate things. Let me show you an example. Let me just show you a really basic example. If I had x squared over x, right? We know that this means x times x, right? I hope. And so we might be able to write our problem like this in expanded form. Well, notice, couldn't we cancel out those x's and it would just leave me with x? Well, that's the same thing as taking the exponents and subtracting them, right? Okay, so let's look at another example. X to the 5th times y to the 12th over x squared times y to the 6th. Now, I did this to start with because I do want to stress that they have to be the same base, right? And so we can't just put everything together. So I only want to look at my base x's first. And what is 5 minus 2? 5 minus 2 is 3. And so it's x to the 3rd power. My y's, base y, I'm going to do 12 minus 6, which is simply 6. And so this would be x to the 3rd, y to the 6th. Okay, here's another one. 18x to the 9th over 27x to the 4th. Now, I threw in some number coefficients because that always tends to throw us. Remember, this rule of quotient of powers does not apply to 18 and 27. They're not like bases. Their exponents are just 1, so we're not going to subtract them. We're going to just simplify 18 and 27 just like we normally would, just like a regular fraction. So 9 goes into both 18 and 27. So 18 divided by 9 is 2. 27 divided by 9 is 3. Okay? And now as far as my x's go, I'm going to subtract their exponents. Now you may be wondering, well, Miss Adams, where do I put this? So what I want you to see is, don't you have more x's on top? So if I am going to eliminate these and kind of in our mind cancel out, won't I have x's left on top? 9 minus 4 is 5. Another little hint is whatever number you say first is where the exponent goes. So, for example, let me explain that a little bit differently. So, for example, we said 9 first, right? And 9 is on top. So 9 minus 4 is 5. And so x to the 5th is on top. If I said 4 first, if I said 4 minus 9, then I would write that answer down on the bottom. Okay, but we do want to, that would give us a negative exponent, and we do want to make sure we're writing it with positive exponents. Okay, so that's quotient of powers. Okay, the next rule is called power of a quotient. This is just like power of a product, and it's basically saying that, just like before, if we have a quotient in parentheses, we need to apply the exponent to every base in parentheses. Okay? Every base in parentheses. So that can get a little bit tricky sometimes. So here's an example. X squared over y to the third power. Now we're going to start using some of our multiplication rules here as well. So I have two bases. The exponent of 3 goes to the base x, and it goes to the base y. So x squared to the third power will be x to the 6th over y to the 3rd. Okay, here's another one. Let me see what I got. 2y over x to the 4th to the third power. Okay, how many bases do we have here? We've got 1, 2, 3 bases. So the 3 applies to the 2, the y, and the x. So this would be 2 to the third power, y to the third power, over x to the 12th. Now, can we actually do 2 to the third power? Yes, we can. 2 to the third power is 8. 2 times 2 times 2. Y to the third over x to the 12th. Okay, I'm going to give you one more. Really kind of building on this. 2c to the third power, d to the third power to the fourth power, over 2c d to the 6th squared. Now just take your time. We're going to do one piece at a time. Okay, so power of a quotient. Let's start. We need to take this 4. The only thing in parentheses that applies with the exponent is what's in the numerator. Okay, so we're going to apply our exponent each place. So 2 to the 4th, c to the 12th, d to the 12th. And I'm going to hold off on this because I noticed that there's a base 2 down here, and I want to show you something with that. And then we're going to put it over, so now in the denominator, we've got 2 squared, c squared, d to the 12th. Okay, now, is there anything more I can simplify? Let's look at it. So first off, d to the 12th, d to the 12th, that's 0. That cancels out. Okay, what about my c's? C to the 12th over c squared. 12 minus 2 is 10. And I can still do the same thing. This is a number base, but it's the same base. So 4 minus 2 is 2. And so that just makes it a little bit easier. And now 2 squared is 4. And we get 4c to the 10th power. Okay, it's going to take some practice.